Welcome back to another BlenderVerse tutorial. In this video, I'll show you how to create a realistic rocket launch effect in Blender. We'll set up the fire and smoke simulation, adjust all the necessary settings, and at the end, I'll share a few tricks to drastically speed up your cycle's renders, especially when working with volumetrics and complex lighting setups. So, here we are in Blender version 4.5.1. Let's start by switching our render engine to cycles. Go to the Render Properties tab, change the render engine from Eevee to cycles, and make sure to enable GPU compute. It's much faster than using the CPU. Alright, let's start by bringing in our rocket model. We're using the legendary Saturn V, of course. I grabbed mine from Sketchfab, and you'll find the link down in the description if you want to use the same one. To import it, just go to File, Import, FBX, then navigate to your download folder and select the .fbx file. Once it's in, you'll see the model already comes in at the correct scale. The real Saturn V is about 110 meters tall, so yeah, it's always super important to work at the correct scale because Blender's simulation system is very sensitive to object size. Alright, now for the engines. We're going to use a simple circle as a base. Hit Ctrl plus number pad 7 to jump to the bottom view. Press Shift plus A, Mesh, Circle, then press S and scale the circle to match the size of one of the engines. Then go into Edit mode, F to fill the circle. Duplicate it with Shift plus D and move each copy into position. If you hold Shift while moving, you can fine-tune the placement really precisely, which is super helpful when you're lining things up. Just in case, cause we are working from the bottom, let's check the face orientation. To fix the incorrect orientation, go to Edit mode, A to select everything and press Shift N. If, like in my case, nothing happens, you should open this little box and check inside. Let's move those circles up just a little bit. Press G, then Z, to move them along the Z axis, just enough so they sit slightly above the engines. Once that looks good, we'll parent the circles to the rocket so that everything moves together. To do that, select the circles first, then Shift select the rocket and press Ctrl P, Object Keep Transform. Now, if you move the rocket, all the circles will follow along perfectly. Once all the circles are in place, you'll have a nice clean setup for your engine exhaust points, perfect for adding smoke and fire later on. To keep things nice and tidy, let's create a new collection. In the outliner, click the New Collection button and name it Main Fire and Smoke. Now, move the circles object into that collection and rename it to Main Emitter. This just helps keep everything organized, especially once we start adding more objects to our scene. Alright, let's quickly set up our animation. Switch to the front view by pressing numpad 1. See those thicker grid lines? Each of those represents 100 meters. If we want our rocket to reach about 400 meters in height, we'll need to set some keyframes. Let's start on frame 96. Then press I to insert a keyframe and choose Location and Rotation. You can actually recognize the shortcut for this by looking at the underlined letter in the menu option. So in this case, the O in Location and Rotation means you can simply press O on your keyboard to confirm it. Next, go to frame 260. Now press G, Z, type 300, and hit Enter to move the rocket upward. Let's also move it slightly to the side and give it a gentle rotation, about 1.5 degrees. To do that, press R, type 1.5, and hit Enter. Finally, press I again and choose Location and Rotation, or just press O to set the second keyframe. Now we've got a simple rocket launch animation. By default, Blender adds a bit of ease in and ease out between keyframes. That means the motion starts slow, speeds up, and then slows down again. For a rocket launch, we actually want it to start slow and then keep accelerating all the way up. To fix that, open the graph editor. Select the second keyframe and adjust its rotation like this, so that the curve starts gently and then steepens toward the end. That way, the rocket lifts off slowly and gradually builds speed, just like a real launch. Perfect. Now, after creating our animation and smoke emitter, we'll need a domain. That's the space where the simulation is calculated. We'll use a simple cube for that. Press Shift-A, Mesh, Cube. You can quickly zoom to your selected object by pressing the period key on the number pad. By default, the cube's origin is in the center, but for our case, we want the origin at the bottom so we can scale it more accurately. To do that, go into Edit Mode, press G, Z, type 1, and hit Enter. As you can see, when you move geometry in Edit Mode, the origin point stays where it is, and that's exactly what we want. Now we can scale the domain properly. Press S to scale it up until it covers the rocket's engines, even at the rocket's highest point. By the way, to fix this clipping in the viewport, simply press N and under View, increase the end value. I think 3000 meters is fine for now. From my tests, it helps to make the domain a bit wider on the X and Y axes. To do that, scale it again, but press Shift-Z to exclude the Z axis from scaling. That looks good. Now it's time to set up the actual fire and smoke simulation. With our domain object selected, head over to the Physics tab and give it a fluid physics, with the type set to domain. Set the resolution to something a bit higher. I'd recommend around 128 or more. I'll go for 256, just to get a nice crisp result. To speed things up a little, let's increase the CFL number. That helps reduce the overall bake time. Since we're dealing with smoke inside a box, we'll need border collisions and also adaptive domain. That one really helps with baking time too. Set the margin to about 2. That decreases the little gap between the simulation and the domain borders. Now, if you check Dissolve, the smoke will actually start to disappear after about a value 100. To make the smoke look a bit more natural and detailed, add just a tiny bit of vorticity. Next, select the collection with our emitter in it, and make sure to set the correct start and end frames for the simulation. To finally bake it, set the cache type to modular, and make sure resumable is checked if you want to be able to pause the bake and resume it later. And don't forget to choose a folder to store your bake in, otherwise it'll vanish once you close the project. Alright, now we're ready for the emitter. Give it a fluid physics as well, but this time choose flow as the type. The flow type is fire and smoke, and the flow behavior should be set to inflow. Let's give it around 8 substeps. That keeps things accurate, especially when your simulation is moving really fast. Since our mesh is planar, go and check this box. We'll reduce the surface emission to 0.5 and give it an initial velocity of -1000 meters per second on the z-axis. Normally, I'd go for something like 2,700 meters per second, because that's roughly the exhaust velocity of the real Saturn V engines. But Blender's simulation system is limited to 1,000, so we'll have to keep it realistic, at least for Blender. And that's it. Our setup's ready to bake.
Alright, so here we are again. The bake is finished and honestly, it already looks really good to me. Now let me show you a quick little trick to watch your simulation fluently without waiting forever like you would for a full render. Let's bring in a camera, snap it to the current view with Ctrl Alt plus numpad 0. Don't forget to turn up the clip end to 3000 meters as well. And personally, I always like to increase the Passepartout value just to make the viewport a bit less distracting. Then choose an output folder. Set the file format to FFmpeg video with an MP4 container and perceptually lossless quality. Now just give it a viewport render. That's such a quick and easy way to get a real feeling for how your simulation actually looks in motion. I love this method. Honestly, I use it every time I'm working with simulations. And wow, this already looks amazing in my opinion. Now let's give it that final touch with the shading. I'll split my view, open up the shading editor, then Shift-A, principled volume, plug that into the volume input, and switch to rendered view. If nothing happens, like in my project here, don't panic. At first, I thought maybe we're missing a light source, so I added a sun. But yeah, that wasn't the solution. Turns out, just reopening the blend file actually fixes it. So yeah, make sure to save before closing.
Alright, so first we want to make the smoke more dense. Crank up the density until you like the look. I'll show you my final settings at the end so you can easily copy them if you want. To shade the flame, we're going to use this really cool volume info node. It basically holds all the data we need. So, hit Shift-A, add a volume info node, and plug it straight into the black body intensity. And there's already a flame. But yeah, it's way too dark. We'll fix that in a moment, but for now, just bring it manually up to about 20. Now this is really important. We're going to change the color management to filmic to achieve that realistic fire look. Give it high contrast as well, so the colors really pop out more. That's nice. The temperature should be around 1500 Kelvin. And to get the most control over how the flame looks, bring in a color ramp so we can tweak it to get exactly the look we want. Turn up the black handle to control how long the flame should be, and bring in the white side to make it more contrasty. And now, with a third slider, a dark one as well, we can bring back all those little details inside the flame. Yeah, I think we're getting somewhere. That's really beautiful, isn't it? Finally, snap in a math node, set it to multiply, and there you have a value to control the brightness. These are my settings for the flame. Now, quickly copy the nodes and reset them to take over control of the density. We can do the same thing as with the flame. And that already looks really good to me. Here are the final settings in case you want to copy them. Alright, now we're ready to render. Turn down the background strength to 0, and I figured out we actually need a really low number of samples to make it look this good. I chose 32, but I tested that even 20 or 25 would work as well. But we do need to activate the denoiser for that, because it does a really great job. I'm using the Open Image Denoiser for the final render, since it's a bit more accurate than optics for this case. Turn off the light tree for faster render times. Increase the max bounces for volumes to a value above 2 to achieve that good-looking result. The higher you go, the better it looks, but I think 4 is a good compromise between realism and speed. When it comes to volumes, you can really save render time, but the higher you set the step rate, the blurrier your volumes will be. I found that a step rate of 2 and max steps of 256 or maybe 512 is a nice balanced value between price and performance. Okay, I'd always recommend activating persistent data when you're doing animations, because that tells Blender not to reload everything for every single frame. It caches the data instead of loading it again and again, which saves a lot of render time. So finally, set up your output folder, hit that render animation button, and here's what our final rocket launch simulation looks like.
1, 0.